Okay, welcome back, Math 10 students. We're going to do lesson 1.2 on fractional exponents. Yes, we can have exponents with fractions. So we're just going to do a little bit of experimenting, and I'll be a human calculator for you right now. We're going to see what some of these equal if I put these into a calculator like 9 to a half and 36 to 1/2. And we're going to see if we can see any patterns. So if we enter this in our calculator, and again, you have all kinds of you have different exponent buttons. Some of them might look like if this was your button on your calculator, it might look like X to the Y. Another button, it actually just looks like this sort of triangle hat looking thing called a caret. That raises it to an exponent. Another button you might have looks like X to the A. All of these are exponent buttons that are different than you'd probably have a squared button, but these are your buttons to raise to any exponent you want. So when we have a fractional exponent, we can put this in our calculator, no problem. And we're going to find out that 9 to 1/2 actually equals 3. 36 to 1/2, your calculator is going to give you 6. 100 to 1/2, your calculator is going to give you 10. Moving over here, 8 to the 1/3, your calculator is going to give you 2. 64 to the 1/3 is going to give you 4. And 1 to the 1/3 is going to give you a result of 1. Now, what do we notice looking at these? These should stand out to you a little bit because 9, 36, and 100 are all perfect squares. And if I were to take their square roots or find what number times itself twice results in 9, 36, and 100, you'd get 3, 6, and 10. And here's some perfect cubes, 8, 64, 1, and I'm getting their cubed root, 2, 4, and 1. So this is exactly the same thing as taking square roots and cubed roots. So raising a base to the power of 1/2 is equivalent or the exact same as taking a square root. Okay, which that symbol looks like this. And remember, we don't write the 2, okay, but there is a 2 here implied. Okay, I'm going to write it in just to make that clear that it does exist. Raising the base to a power of 1/3 is the exact same as taking the cube root. And this one, we always write the index, anything but a square root. So we put a 3 right there. Okay, and raising a base, what we're actually going to discover to the power of 1 over n, doesn't matter what n is, it can be any positive integer, is equivalent to taking its nth root. So you take 4th root, 5th root, 10th root, anything you want. And of course, this is just the same thing. We have our root symbol, and our index is going to be whatever n is. Okay, so then we get this box here showing us how do we move from one notation to the other. So powers with rational exponents. Rational just meaning that just says fraction is what we're dealing with. Okay, and so we have x raised to the power of 1 over n. It can be expressed as a radical, okay, which looks like this. We have the nth root. Or more generally, we're actually going to see something, and this is due to exponent laws, x to the m over n, noticing we could have a different number than 1 in the numerator of the fraction, is expressed in 2 different ways. And you actually can choose this way or this way to represent it. Now, I will say that I find the first one here on the left is what we're going to use most of the time. It's faster and easier. Usually the numbers are smaller, but I'm going to show you a couple examples. There's a silly helper with this called shoes and hats or boots and hats. I've heard teachers call it both things, but when we think of this fraction, we would think of the hats being on top, okay, and the shoes being on the bottom. So if you think of this radical kind of like a house, okay, we leave our shoes, here's the quote here, we leave our shoes at the door, so they go outside here as the index, that's where that number goes, and we hang up our hat or leave it on is one way to think of it. So the hat goes up top, or leave it on top of the X if the X was the person. So you're going to hear me say this a lot in class and then throughout this lesson, but hats and shoes or boots and hats, same idea that we make sure we know which number goes where every time because they can be mixed up sometimes. So Let's actually do this down here with this 8 raised to the power of 2 over 3. We're going to write it in radical form, okay, and in both different ways and evaluate. So the first way here, okay, I'm going to write it as, I'm going to write a cubed root because this is my, I'm going to try, let's change colors here. Okay, so if I have this 8 raised to the 2 over 3, okay, this is my hat, the 2, and this here is going to be my shoes or boots. Okay, so let's go back to blue. And so my 8's going to go inside here, and I'm going to do the first form where I put it all in brackets and then raise it to the hat. I put my hat up top, the 2. Okay, so what does this tell us right now? It tells us I have to simplify brackets first, following BEDMAS, and then the exponent of 2. So if I do this, what number times itself 3 times gives me 8 is, of course, 2. And then I'm going to raise that 2 to the power of 2, which is 2 times 2 is 4. So that's our first method using this form in radical form. The second method we saw up above is what if I leave the hat on? So I have my 8 here, but I leave my 2 inside, okay, inside the root this time. So now I have to, you can think of the root as being its own brackets, okay, that I must figure out what is 8 to the 2 equal before I take the cubed root. Well, we know that 8 squared is 64. Okay, and now I have to figure out what number times itself 3 times gives me 64. Again, a way to think of this is what number raised to the power of 3 is going to give me 64. Sorry, that's a question mark. Okay, and of course that's going to be 4. And you notice we get the same answer no matter which method we use. Okay, but like I said, this method number 1 is going to be the one we use the majority of the time. You can notice that we kept the numbers smaller in this method, whereas over here we got a number as big as 64 to deal with, which mental math, easier with smaller numbers. Okay, let's do a few more examples. So we're going to just convert these from exponential to radical and then evaluate, but we're going to do it without a calculator. So these look pretty technical, but they're not that hard at all. So again, we're just going to set this up in our favorite form. So I'm going to write my radical. Okay, I'll put the 1000 inside. I'll put my index or my shoes at the door, which is a 3, and this is all being raised to the power of 1, which we know changes nothing. So we can actually ignore this 1 and get rid of it. So now all it's saying is what number times itself 3 times gives me 1000, and of course that's 10. If you don't remember, you can always, I'm going to scroll up really fast, you can always refer to this chart, which will be accessible. And that's why we included 1000 here for that perfect cube. Okay, let's go back down. Sorry about that. B, okay, we got one of these decimal ones. No big deal though, we can handle it. So again, I'm going to put this square root. Okay, I'm not going to write my 2 though. We know there's a 2 there. This is a square root. So my shoes of a 2 go at the door. And again, I'm raising it to the power of 1, which isn't going to change anything. So I just need to figure out what number times itself gives me 0.25. Well, we know 5 times 5 is 25, but notice the decimal. So we must go, because we have 2 decimals here, I must have only 1 when I take the square root. Okay, and that's it, that's all. We're done because raised to the power of 1 is the same thing. Let's take the fourth root over here. So we're going to change this fraction. We're going to put it in a big root symbol. And this is the fourth root. And again, it's being raised. Sorry, that bracket's not that good. Put it over 1. And this is going to be 16 over 81. Okay, now we remember if we have a fraction, we just take the root of the top and the bottom separately. So where this is going to turn into the fourth root of 16 divided by the fourth root of 81. And that's going to give us, and again, what number times itself 4 times? That's going to be 2. What number times itself 4 times gives me 81? That's 3. So our final answer is 2 over 3. Moving on to D. So now we have a hat that's not 1, it's a 3 this time. So let's try this out. We're going to write our radical symbol, put in our radicand of 81. Our index is 4. That's where we put our shoes. And this time we got to put up our hat outside, way up here as an exponent. So let's figure out the 4th root of 81 first. Well, we just did it in the last question. That's 3. So now I need to take 3 and raise it to the power of 3, or 3 times 3 times 3, which is 27. Not too bad. Okay, now we have a negative here. Nothing different. Just be careful with your sign with these. So we're going to take a 3rd root of negative 27, and my shoes is a 3. My hat's going to be a 4. So let's first take the cubed root of negative 27, which is negative 3. Raise that to the power of 4. And finally, negative 3 times itself 4 times. It's going to be positive because there's 4 negatives in this case. And 3 times 3 is 9, times 3 is 27, times 3 is positive 81. Okay, we have a decimal, but the only thing you have to do here is turn that into a fraction. And that's easy. This is 6/10, right? Because we're in the decimal system is the number system we use. So 0.6 can be written as really simple, 6 over 10. I can show this in more detail in class. And that we're just going to reduce that fraction, divide the top and bottom by 2 to get 3 over 5. So that's my fractional exponent is 3 over 5. So let's try that out. We're going to take the negative 32, put it inside. We're going to put the shoes at the door, which is a 5. And then we're going to put the hat up top, 3. Okay, and then now what number times itself? 5 times is negative 32. Well, that must be a small number, and it is the smallest we can do, which is negative 2, outside of being 1, of course. Negative 2 times itself 5 times is 32. You can check that. And now we're going to raise that to the power of 3. So I have 3 negatives, so my result's going to be negative 2 times 2 times 2, which is 8. All right. Almost done here. We're going to write these two in exponential form. We're not evaluating. So really, can you find, all you got to do is find your shoes and your hat, and whatever's inside, put it in brackets. Okay, so my radicand, the negative 25, goes inside, and my hat goes up top, and my shoes go on the bottom. That easy. Now we're in exponential form. We have an exponent instead of a root. Over here, don't forget that there is a hidden 2 right there. So again, we're just going to take our number inside, okay? And then this is still on top of its head. So that's going to be our hat. So it's going to go up top, and the shoes always go on the bottom. So 5 over 2, 3 to the power of 5 over 2. Really simple. We're going to do a quick little word problem here. Not very hard because we're just doing a substitution. Okay, so what this is saying, we got biologists use this formula where B equals 0.01 m raised to the power of 2 over 3 to estimate the brain mass, which is B in kilograms. So now we know what B stands for. That's our brain mass. Okay, and a mammal with a body mass of m. So the body mass is m and the brain mass is B. So that makes sense using B and M. So we want to estimate the brain mass. In other words, what's B for each of these animals? So we got a husky. Okay, I had a couple huskies growing up. Awesome dogs. And so all this is saying we have a body mass of 27. Okay, so we're being told what the B value is here. Okay. Oh, sorry. No, M value. This is M. Apologies. We're told right here that body mass is M in kilograms. So M is equal to 27 kg. And we need to find B. Okay. That's what it's asking. Estimate the brain mass of each animal. So we're just going to write our formula first. Always good when substituting. Just copy the formula we're using. And then we're going to make the substitution. Raised to the 2 over 3. And so now we're going to do that substitution. B is equal to 0.01, and M in this case is 27, raised to the power of 2 over 3. Okay, and we can convert that to a radical form. So this 0.01 is just multiplying. It's a coefficient out front. And we're going to put this all in brackets, the 27. The shoes is a 3. The hat is a 2. And now we just need to evaluate this using the right steps. So we're going to take the cubed root first, then raise it to the exponent of 2, then multiply it by 0.01. And so I'll just do one step at a time actually here. 0.01, and that's going to be 3. 3 times 3 times 3 is 27. And then we're going to square the 3, 0.01, and 3 squared is 9. And finally, we don't need a calculator for that. We get 0.9 kilograms as the approximate mass of the brain of the husky. Let's do one more. It's going to be the exact same thing. So I'm going to first write my formula, 0.01 m raised to the power of 2 over 3. This time we're told we're doing a polar bear, which has a body mass of 200 kilograms. So m is equal to 200 kg. So let's substitute that in. So b is equal to 0.01, substitute in 200 raised to the power of 2 over 3. All right. And if we're going to need a calculator because 200 is not a perfect cube. Okay, but we're going to rewrite it in that form. So we put the 200, shoes are a 3, the hat's a 2, and we're going to need a calculator for this. And what you'll end up actually getting is just looking at my notes here. Yeah, so we're going to get approximately, we're going to take the cubed root first, then square it, and then multiply it by 0.01. So we're going to end up getting 0.01. And that's going to, if you take the cubed root of 200, it's approximately 5.848. Now leave that number in your calculator because you have to square it and then multiply it by 0.01. And you'll end up with approximately 0.34 kilograms. Okay, use that approximate symbol again. That concludes the 1.2 lesson. We'll see you next time.